Okay, so today we are going to look at our trigonometric identity, or one of them. And the one we're looking at today is the reciprocal of the trig ratios. So this is one identity of a few. So the first identity is the reciprocal. So our learning intentions, we want to learn or gain the knowledge of reciprocal trigonometric ratios and the skill in calculating values using this knowledge. We will be successful if we know what the reciprocal trigonometric ratios are, know the graphs of reciprocal trig ratios, and correctly solve problems using these ratios. Okay, so if I had sine theta is the same as opposite over hypotenuse. So if I was to do the reciprocal, so the reciprocal of, let's say, the reciprocal of A, yeah, we've got A, the reciprocal of A is 1 over A, yeah, so that if we multiply these two together, we get 1, okay, so the reciprocal of a function, f of x, or to the negative 1 is the same as 1 over f of x, so that's the reciprocal, yeah, and if I had sine of x, well, 1 over sine of x is a reciprocal, and you'd write it as sine of x or to the power of negative 1. These are the reciprocals. Do not confuse them with the inverses. You might see this in books. You might see f to the power of negative 1 of x or sine to the power of negative 1 of x. This is the inverse, not the reciprocal. Whereas if you had 1 to the power of negative 1, that is a reciprocal. Yeah. So try not to get those two confused. Okay, so if we had sine theta, and that was going to be opposite over hypotenuse, well, 1 over sine theta, so 1 over opposite over hypotenuse, so 1 divided by a fraction. What we do with the fraction is we flip it, and we change it to a sine, so that's going to be hypotenuse over opposite. So the reciprocal of sine theta is also known as the cosecant of theta, and that's going to be the hypotenuse over opposite. So we call this the cosecant. The short word is cosec, so cosec theta, and sometimes you can see it written as CSC theta. Yeah. So the reciprocal of cos is the secant. So if cos was adjacent over hypotenuse, the secant theta will be hypotenuse over adjacent. And then the reciprocal of tan was opposite over adjacent, so the reciprocal of tan is the cotangent, and that's the adjacent over the opposite. Okay, so it's written as cosec theta, sec theta, and cot theta. Note the third letter of the symbol, right? Cosec is the reciprocal of sine. The middle letter is S, it's the reciprocal of sine. Sec theta, the third letter is C, it's the reciprocal of cos. Cot theta, the third letter is T, it's the reciprocal of tan. Okay, now, their graphs. Okay, I've sketched slightly the sine curve under here. Okay, so the reciprocal of sine, or the cosecant of theta, is mirrored around it. So you can use your calculator, you can go, make sure you're in degrees mode, we can go 1 over sine of 0. So that's the syntax error, so there's, sorry, so I need to put it in brackets. We get a math error, so we mean there's an asymptote here. What happens if we have sine 0.1? Just off it, right? It's a very large number. Okay. If we get to sine 90, 1 over sine 90, we get 1. Yeah. And basically we get, it goes to infinity, comes and touches at 1 and goes back up. And the same thing with from the third and fourth quadrants. Okay. So if I wanted to find the reciprocal graph of the secant, okay, so here I've sketched in my cos curve. Well, as you can tell, that's decreasing, so up here will be increasing. It will be an asymptote at 90 once again, and also at 270. Here it's decreasing to -1 and then increasing, so it would be the opposite. It would be increasing up to -1 and then decreasing from that. And then obviously it creates another curve here. Okay. With tan, so I've sketched in the tan curves. Yep. Now, if I wanted to figure, so remember that tan of 90 is undefined. Yeah. So at 90, if I wanted to do 1 divided by an unknown number, I can't really do that. So there's another asymptote there. But what happens is we get this wavy curve where the asymptotes are occurring at those points. Yeah. So we're just basically reversing it and then moving it to the left. Okay. So the reciprocal has the same sign as the corresponding trig ratios. So here, where sign is increasing, yeah, it's in positive position, so is its reciprocal. And here, sign was decreasing, and so is its reciprocal. And the same with cos. So one important thing is obviously our trig ratio, our exact triangles. So if we had cosec, sine theta was opposite of hypotenuse, so the cosec of 45 is the opposite, the hypotenuse over the opposite, so that's square root 2. Sec is going to be the hypotenuse over the adjacent, so that's going to be square root 2. And cos 45 is the adjacent over the hypotenuse, so that's still 1. Okay. And obviously if we change that to radians and made it pi on 4, you'd get the same thing. So the other exact triangle, okay, so we've got cosec of 60, so that's going to be the hypotenuse over the opposite. Yeah. Sec of 60, so that's going to be the hypotenuse over the adjacent. And then we've got the cot of 60, so that's going to be the adjacent over the opposite. And obviously we've got 30, so the cosec is a hypotenuse over the opposite. The sec of 30 is the hypotenuse over the adjacent, and the cot of 30 is the adjacent over the opposite. Yep. Now, these are reciprocals, and that these kind of match up. Okay. That's important when knowing the other trig identity of complementary angles. Okay, let's do some examples. We want to find cosec theta, sec theta, and cot theta if we have this triangle. Okay, so here's our theta. So cosec is going to be the hypotenuse over the opposite. So here we go, 52 over 6. The sec theta is the hypotenuse over the adjacent. And the cot theta is the adjacent over the opposite. And that can be simplified to 2 over 3. If we have this question, if sine theta equals 4/5, we want to find cosec, sec theta, and cot theta. So, first thing we do is we draw a right angle triangle. So we know that if I've got theta, I've got the sine theta is 4 over 5, so the opposite over the hypotenuse. And using Pythagoras, I can figure out that this is 3 units. So if I wanted to find the cosec of this angle, so that's the reciprocal of that, so flipping that on its head, it's got 5 over 4. Sec theta as cos, so cos was 3 over 5, so reciprocal of that is going to be 5 over 3. And cot theta, well, tan is going to be 4 over 3, the reciprocal of that is 3 over 4. Okay. here we've got a question. We want to simplify sine of x and cosec x. Well, sine of x, that's fine, but cosec is x is the reciprocal of sine of x. So we can go sine of x multiplied by 1 over sine x. And as fractions multiplying fractions, we can multiply the tops together. Sine x times 1 is sine x. 1 over times sine x is still sine x. Sine x over sine x is 1. So therefore, sine of x times cosec of x equals 1. Thank you.